2I, but I'm not getting the right answer.
Well, before we go to the next lesson, Musharif has one I'll do, so I'll do that one. Okay. Right, what's the question, Musharif?
Sine 2a equals
Yep.
24 over 25. Find tan b.
Tan A.
Yes.
Okay.
A and acute.
They're all acute here, which is convenient. So we have,
Cos A or tan
well, the one Musharif asked me to do is to find
J.
J.
A?
Yeah. So, you know that 2 sine A cos A equals 24 over 25. That means you know that sine A cos A equals 12 over 25 if you divide both sides by 2. Is that okay so far? Yeah, that's okay, yeah. Now, what I'll do next is I think I'll square everything. So now I get sine squared A, cos squared A equals 144 over 625. Now you might say, well, why do that? Because I can change cos squared into sine squared if I like, which I do like to. So I have sine squared A 1 minus sine squared A equals 144 over 625. So I get sine squared A minus sine 4A equals 144 over 625. So we get sine power 4A minus sine squared A plus 144 over 625 equals 0. Or if you want, that's 625 sine squared A squared minus sine squared A minus 625 sine squared A plus 144 equals 0. What type of equation is this? It's a quadratic, except it's not x, but what's the variable?
Sine squared.
Sine squared, yeah. So if I solve this now, and hopefully it will give me a nice answer. (16 over 25) and 9 over 25. Now, just be careful. We're saying sine squared A equals 9 over 25. What the heck? Hang on. Or 16 over 25. So this actually gives us 4 answers. We have sine A equals 3 over 5. Sine A equals minus 3 over 5. Sine A equals 4 over 5. Sine A equals minus 4 over 5. We have 4 answers altogether in total. But 2 of the answers we can throw away straight away. What are those 2 answers? Yeah, forget about this guy and forget about this guy. So it has to be this or this. Now what was I looking for? I was looking for tan A, wasn't it? Well, if I draw the triangle here, this is 3, 5 and 4, and this one here is 4, 3 and 5. Seems like we get 2 answers for tan A. Tan A is 3 over 4, or tan A equals 4 over 3. Now, I don't know if both answers will work, because I said A is acute, and 2A needs to be acute as well. So, for example, if I calculate here, just roughly, tan inverse 4 over 3, I get 53 degrees. And if I do tan inverse 3 over 4, I get 37 degrees. This angle is no good, because if I make it 2A, if I double the angle, it's not acute anymore, it's obtuse, because it's 53 degrees. If I double it, that's 106 degrees. But this angle here is only about 37 degrees, so 2A is also acute. So tan A is 3 over 4 is the answer here. This is a very hard question. So you probably want, can you still see it? No, it's a bit too small. You probably want to write that down. Well, the top is just a question, so this is the answer here. You have this written down, Adnan? You're writing it down.
Can we do the second lesson?
Oh yeah, we're going to do it. It's very short for babies. Well, maybe not babies, smart babies. Do you have Moodle open there? Can you open up the formula book, please? I just want to check something. I don't think I have Moodle open. No, I closed it. Do you have Moodle there? Is there a formula book under books and resources for maths for engineering? Thank you. I just want to see if the formulas I'm going to give you are they in the book? Did they add them in or not? What? No. So what is in the book? No, it's what I taught. Sine rule, cosine rule, double angle rules, and compound angle rules are in the book. The next thing I'm going to show you, it's
The
not.
tan rule or
Huh?
the tan
Which tan one?
tan 2a
Tan 2a is.
and
Your sec squared rules? No. That's why I don't do it. Here you go. Right. Next one.
the sine a plus b, are they?
Yes, they're called compounds. They are. Yeah. Okay, next. Now, let me just write this down. Oh. You have that? Yeah? Okay. Got that? Alright. So, there's a couple of ways to do this one, but because there isn't a formula in the formula book, I don't want to show you how to do this by using a formula. What we're trying to do here is change the product into non-product. So, here we're multiplying cos's, and we don't want that. We want to change it into adding or subtracting cos's or sines. We don't want to multiply here. So, what we do, we call this angle A plus B, and we call this angle A minus B. And first we try to find A and B. Now, you can do this as a simultaneous equation. A plus B equals 3x, A minus B equals 2x. But if you think about it, you can possibly realize what it is. It's going to be, let's see, actually, I said we could. Oh, did I write this down wrong? That seems a bit weird. 3x and 2x. No, I'm sorry. I'm doing it not the way I meant. I'm very sorry. What I mean to say, which is easier, is we call this angle A, and we call this angle B. Okay? And if you think about your compound angle formulas, which one has cos in it? You have cos A plus B, sin A plus B, tan A plus B. Which one has cos in it? Huh? Cos A plus B. You see that there? Yeah, so cos A plus B. Oh, and to give you a little hint, we call the bigger one A and we call the smaller one B, because you could have it the other way around. So cos A plus B is cos A cos B minus sin A sin B. But if we're calling this A and this B, then we can say for this question, cos A plus B, what's cos A plus B? That would be 5x equals cos A cos B minus sin A sin B. Do we have what we need? No, but we're not too far away. What's the problem with what I wrote? 4 is one problem, and what else is missing or extra that I don't want? I don't want the sines. Let's write down the formula for cos A minus B. What's cos A minus B for this problem? Cos A minus B? X equals cos A cos B plus sine A, sine B. We have the same problem, but now if you look at both, maybe we could use both to make the answer. What do you think? Is there any way to make only this, not have the signs? Yeah, if I add them together, then I'll get cos 5x plus cos x will equal 2 cos 3x cos 2x. And what happens here? They cancel. So I nearly have it. One thing left to do. What's wrong with what I have? It's nearly what I need. Multiply by 2. So then this becomes 2 cos 5x plus 2 cos x. So what you've done is you've taken a product, which means multiply, and you've changed it into a sum. So for some problems in maths, it's easier if you change the multiplying into a plus. And we'll see those problems later in the chapter. But for now, I just wanted to practice converting. So I'll do another one, but write this down as your first example. I think we'll do a cosine next or something. Did you write this down? It's too easy to write down.
This is a formula.
No, there's no formula because there's no formula in the book. So I don't want to give you a formula. I want to give you a method, a process. This is the process. You know what I mean? Yeah. Yep. Okay. Continue, Adnan? Yep. So, let's do one that has a cos and a sine in it, like B. 6 cos 5x. No, that's a little bit too easy. We'll do F. 2 sine 3x cos 5x. Is that okay? Yeah. So, which one's A and which one's B? Yeah, we'll call this one A and we'll call this one B. And which formula has a cos and a sine in it? Sine, yeah. So you have sine A plus B is equal to sine A cos B plus sine B cos A. Not quite, but nearly. Again, we can do A minus B. Sine A minus B will be sine 2x. equals sine A cos B minus sine B cos A. Now, I want to make this. So, what should I do here? No. Because if you add them, you'll be left with sine 5x cos 3x, which is not what you want. Minus them. Minus is what you want here, because these will cancel, and here you'll have 2 sine 3x cos 5x, and this is exactly what you want. Equals
How did we get? How did we get?
How did I get what?
2 sine x cos 5.
This plus this. It's a minus. So plus minus minus. These cancel when you minus.
It's sine 2x, not x.
I know I can't do 2 things at once. I can't answer his question right and 2x. Please, I'm so tired and busy. Have mercy on me. Sine 2x. Yep. So this is the answer. You have this? Yeah, continue. So, you can see they're actually quite simple. I didn't actually put in any tans, because, yeah, this doesn't come up for tan, it's only sine and cos. I want you to try a couple, but they're very, very short. Let me see which ones. What ones did I do? A and F, wasn't it?
Z and Y. Really?
Hold on. V to Z, please. V to Z. V W X Y Z.
I will go from there to B.
Okay, fine. Z to B if you want. Can you try those now, please? I'll zoom in. V to Z. You can open your phone or you can write them down. Actually, maybe you should write them down. No, Musharif, could you write all the questions down? Oh, you have it open? Okay, grand. Adnan, you're writing them down?
I can't open more than that.
Okay, will I turn the projector off?
Yeah.
Could you get the switch then?